Right, so here we go with the key for 5.1. All right, so let's get started. This is the first one here, looking good. All right, so it says we're talking about angle bisectors and perpendicular bisectors. It says given, let's see, let's just mark all the information. We know that this is 53.4 QT. So QT is 47.7 and QS is 53.4. We basically know that S is equidistant from the endpoints, which means we know that TQ and TP are the same because this is a perpendicular bisector. It's bisecting it, so find PQ. It's just going to be 47.7 times 2, right? So that's 2 times that. So 95.4. Okay. And we'll actually, let's do this. Let's switch colors. I'll just do the same diagram. All right, so it says given M is the perpendicular bisector. So again, given that it is the perpendicular bisector, and PQ, so the whole thing is 25.9. So that's for the whole thing. Find SP. Well, if it's a perpendicular bisector, SQ it says also is 25.9. So again, if it's a perpendicular, oh, sorry, this is not right. So just ignore that. So if that's 25.9, we know that SQ and PS are the same, so it's going to be 25.9. Given that M is the perpendicular bisector of PQ, let me actually, I'm going to have to clear some of this off. But we'll have a good key and you can watch it, so that's all good. So we have M as the perpendicular bisector, so it means it's splitting it, and it's perpendicular, which is already marked. It says PS equals 4A, and QS equals 2A plus 26. Well, the thing we know is that S is equidistant from the endpoints, from Q and P, so they're going to be the same. So in other words, we know that 4A equals 2A plus 26, so 2A equals 26, so A equals 13. So it says to find QS, well, let's plug it back in. Actually, the easiest one to plug in is just 4 times A. So we have 4 times 13, which is 52. 4 suits, 13 cards each, 52. Yeah, all right. Again, this was just 2 times 47.7, just for people checking. But okay. All right, so let's go. Move it on. It says that BD does bisect this angle, so we know that those angles are congruent. It says CD is 21.9. Find AD. Well, again, if this is an angle bisector and D is on the angle bisector, then these two distances from the angle bisector to the sides are going to be the same, so that's also 21.9. It says that AD is 61. Okay, and so 61, and this is 61, so these are congruent, so I'll just mark them congruent. It says ABC, the whole angle is 48, right? So the whole angle is 48 degrees. And then so it says find CBD. So CBD is just half of that, so it's going to be 24 degrees. And again, I know it's half because it is an angle bisector because these distances are congruent. So because the distance from this point to the edge are congruent, that means I know that it is an angle bisector, and if it's an angle bisector, then those have to be congruent. Okay. It says given that DA equals DC, so these are congruent. And then the measure of DBC is 10y plus 3, and DBA, so this one is 8y plus 10. Again, we know that this is an angle bisector because these distances are the same. So again, we can just set them equal to each other. So we have 8y plus 10 equals 10y plus 3. Again, we know that they equal to each other, so that's a good equation. So we get 2y equals 7, 10y plus 3. Let me just make sure we're good here. 8y plus 10 looks good here. So yeah, y just equals 3.5. Again, we're not quite done yet. It does say we want to find DBC, which is going to be 10 times 3.5 plus 3, which is 35 plus 3, or 38. So we know that it's 38 degrees. All right. Given line T is perpendicular bisector. Okay, so GK is 8.25. And this is the perpendicular bisector, so that means GJ has to also be 8.25. Because they're equidistant. Again, if this point is on the perpendicular bisector, then it is equidistant. So we know all that. All right, so let's clear this. It says given that line T is the perpendicular bisector, okay, of JK, so all the same stuff applies. We know that that is going to be the same because this is the bisecting that and it's perpendicular. It says that JG is x plus 12 and KG is 3x minus 17. Find KG. So in other words, we know that G is equidistant, or is on the perpendicular bisector, so it's equidistant. So we know that these are congruent segments, so you can set their measures equal to each other. Right? So we can get, let's just, we get 2x over here, and we can get 29 over here, right? So x just can equal 14.5. We're trying to find kg, so we plug it back in. So we get 3, or let's just do x plus 12 is probably the easiest way. X plus 12 is just going to be 14.5 plus 12. So we get 26.5 for kg. So that is, that. All right, now it says given that GJ is 70.2 and GK is 70.2. So in other words, given that they are congruent, so let me just get rid of some of this. So given that that G is equidistant, right? So it sort of depends on what we know, but in this case, we know this essentially. Then if JH is 26.5, then what is JK? The whole thing, well, we just double it, right? It's just going to be 2 times 26.5, 53. Cool. All right. Next page here. All right. It says given that this angle RSQ is congruent to this angle, so this is an angle bisector. Oh, sorry, RSQ is this angle and this angle. My fault. So in other words, it is that Q is on the angle bisector. So if TQ is 1.3, so is RQ. So 1.3 is what we're looking for. Okay. All right, so now it says given that this angle RSQ, this is 58, so this part is 58. And then it says that both RQ and TQ are both 49, so they're congruent, meaning that this is on an angle bisector, which means this angle has to also be the same as that one, or 58. So it says find RST, which is just going to be 58 times 2, or 116 degrees. All right, and now let's clear that again. This is why video is good, because you can see that what I'm doing, not just the end result. It says RQ is congruent to TQ, so we know that this is going to be on the angle bisector. So again, we know that these two angles are congruent, and actually that's what they give us is QSR, which is this angle over here, and they give us QST, which is here. So we know that these two expressions are going to be equal to each other. So in other words, 9A plus 48 has the same measure as 6A plus 50. So again, I can get 3A equals 2. So A equals 1.5. And we want to find QST. So QST is 6A plus 50. Now, it doesn't really matter. They'd be the same. So it's going to be 6 times 1.5 plus 50. 6 times 1.5 is 9. Plus 50 is 59. So the measure of angle QST equals 59 degrees. It's a little sloppy, but that's what it is. All right. It says that PQ is the perpendicular bisector of ST. So this is perpendicular and it's bisecting ST. So we know that what I know is that P is on the perpendicular bisector. So we know that these points are going to be equidistant, right? Or these segments are equidistant from the endpoints, S and T. And we also know that SQ, or because Q is also on the perpendicular bisector, then SQ and TQ are also going to be congruent because those would be equidistant. So two equations I can make are 3m plus 9 equals 5m minus 13. And then also 6n minus 3 equals 4n plus 14. So we get 2m equals 22, m equals 11. Then in this case, we get 2n equals negative 17. Oh, wrong. Wrong. Big time wrong. Okay. We would get 2n over here, and so we would get positive 17, so n, which would end up maybe being what I did anyway, but still. 2n, so we get 17 over 2, which is fine. You can of course, have done 8.5. All right, so given this diagram, this one's a little more complex. We want to say that what we do know is that KZ, all right, so this line right here is the perpendicular bisector of all of these, of here, here, and here, of GN, HM, and LJ, all of those. All right, so given what we know that this is perpendicular bisector, so that's got to be 36. We know that this is congruent to this. We know that this is congruent to this. All right, so here we go. So JK is the first thing we are asking to find. Well, if this is 38 over here, then this will be 38 as well. And that's because if this is on the perpendicular bisector, which means we know that K is the same distance from J and L, right? So it's the same distance. So that's going to be 38. And then GN is going to be, well, GN's this whole distance, so that's 36 times 2, or just 72. ML is this distance right here. Again, if this is 38 and this is 38, then this is also going to be 38. And again, you could say that like HK is going to be 76, and so MK has to be 76, and if that's 38, I just subtract, but you can realize, of course, that they are the same as well. So ML is just going to be 38. HY, if that's 24, HY is going to be 24 as well. JL, well, if that's 12, then that is 12, so the whole thing is going to be 24. And then NM will just be, well, in this case, the whole thing, right? We know it's going to be the same as GH here, but we know the whole thing is 114. So if we just do 114 minus 38 minus 38, in other words, minus 76. So we got 114, yeah, minus 76. So we know that what's left over also has to be 38. 38. All right, sounds great. All right, so in this case, we're going to actually have to draw this out. We're saying JK is perpendicular to XY. So we know we have X, we know we have Y, and we know that JK is perpendicular to it at its M point. So we know that it's perpendicular bisector. So this is M, and then it's J up here, K. Well, it's just line JK. I don't really know what his points are. So which statement is true? JX is congruent to KY, not necessarily. JX and JY would be congruent. JX and KX would be congruent. No, not this way, because what we're looking at is these. Like, we know that, these would have to be congruent, and these would have to be congruent, but not necessarily all of them don't have to be. JM is congruent to KM, not necessarily, right? Because that's not what's being bisected. And then JX is congruent to JY. So that's the one we're looking for right there. We know that's this, it's this and this are congruent based on how it's set up. All right, what information do you need to conclude that EF is the bisector of DEG? Well, again, if we just sort of sketch this out, we get D, EG, and then EF, we're just checking to see that if it's the bisector. It's not drawn great, but okay. So in other words, if we know that measures of angles DEF and FEG are going to be the same. So if I look for that FEG and DEF, it looks like that one, right? In other words, if FEG, this angle is congruent, or it has the same measure as FED or DEF, this one, then so it looks like G. All right, awesome.